Hi everyone, welcome back to Teaching Math. In this final part of our exponent series, we're putting everything together, multiplying, dividing, and raising monomials to powers. As a bonus, we'll also look at what happens when negative numbers are raised to powers, because those parentheses can really change things. So let's get started. Extra examples, multiplication and division of monomials. What does monomial mean? It means mono, one single algebraic term, which is like 2x raised to the third power. All right, so let's go ahead and start our first example. As we can see here, this is a multiplication. Just because there's no multiplication sign in the middle, it doesn't mean it's not, because we do have parentheses. Let's go ahead and find the rule. It says multiplying monomials, same base rule applies, add the exponents. So we do have the constant in here, the 5 and 2. What I usually do here is I organize the information that I have. I know this is multiplication, so if I move things around, it will not change the answer. And so that's what I'm going to do. First, I'm going to bring the 2 and 5 together and again follow the same base rule and bring the bases, same bases together, which in this case are the x's. All right, 2 times 5 is 10. And then I'm going to go ahead and it says add the exponent since it is multiplication. So there's 3x's plus another 4x's. And this will equal 10x, which I don't need to write the multiplication sign in there. You don't know, this is mono, single term, monomial, raised to the 7th power. Let's check our work. Yep, there's 3x's plus 4 equals 7. All right, so let's go ahead and do the second example. This seems a bit more complicated, but it's not, again, because we will achieve the same goal by separating and identifying what is happening here, right? So again, we're going to separate 3 times 4, and then same thing, we're going to bring the same bases together. Remember that when a doesn't have exponent, it's exponent of 1 raised to the first power. And then let's go ahead and say b raised to the first power and times b to the third power. 3 times 4 is 12. And then we're going to go ahead and add the exponents. 1 plus 3. Okay, 12. And this will equal 12 a to the third power, 2 plus 1 is 3, and then b to the fourth power. Again, this looks like complicated multiplication and division of monomials. We're dividing the monomial, same base rule applies, and subtracting the exponents. Okay, let's see if we can do this. All right, third example. So 12x raised to the 5th power divide 3x to the 2nd power. Again, I'm going to come back to how do we organize the information? How do we separate things and then put them back together? So let's go ahead and do that. I'm going to say 12 divide by 3 and then same base rule times x raised to the 5th power and then x raised to the 2nd power. I'm not doing anything different. 12x to the 5th power means 12 times x to the 5th power, and same goes for 3x to the 2nd power. It's 3 times. So I'm just going to put that times in the middle. It first says divide monomials. Okay, we're dividing 12 divided by 3 equals 4. And then we're going to subtract the exponents. I'm going to show that. And here we are, 4x to the 3rd power. See how when we separate, everything becomes easy. Okay, let's go ahead and do the fourth. 15a to the 4th power, b to the 3rd power, divide 5a to the 2nd power and b. Again, I'm going to separate everything just to see what I'm dealing with. same bases together, A's with A's, and then B's with B's. Okay, once I do that, I can actually clearly see what's happening here. 15 divided by 5 equals 3. Then we're going to go ahead and subtract the exponents. Remember, there's 1 in here, and that will equal 3a to the second power, and then b to the second power. Okay, here's another one that might be not hard, but confusing. Again, we're going to work on our knowledge about the rules, right? And we're going to apply the same rules. Look at this one. It's very interesting. It's a lot of fun once you understand it. So the fifth example has powers of powers. So we're going to evaluate first to understand what do we see here, and then instead of writing x for multiplication, I want to write like that, so I won't confuse with the other x. Okay, let's start with order of operation. We're going to do the exponents first. Now, if there was the same base inside the parentheses here, I would have started with inside the parentheses, but they don't have the same base. So we're going to raise everything to the second power first. So x to the second power raised to the second power, and then y to the third power is raised to the second power. And then I'm going to rewrite everything else the same just to have it. Okay, so let's go ahead and multiply the exponents. I'm going to show you the multiplication, but you don't really necessarily need to do this step. But once you're learning, the time that you're learning, you can do it. All right, here we are. So x to the fourth power, right, times y to the sixth power times x to the third power times y. So now let's get the same terms together, same bases together. X to the fourth power times x with the third power times y to the sixth power, moving the y to the other side. Don't forget it's 1 in here. Okay, what is the rule for multiplication with the same base? We're going to add the exponents. This means here x to the fourth power plus 3 and y to the sixth power plus 1. This will equal x to the seventh power and times y to the seventh power. You can rewrite it just like that. That's it. Again, we leaned on how to organize the information and then following the rules of powers. Okay, I'm going to rewrite the last example. In fact, pause the video and try it on your own. See if you can apply the same rules. Again, organize the information and apply the power rules. Okay, example 6. A raised to the fourth power Okay, pause the video here and try on your own. So again, I'm going to go ahead and multiply power of power rule, following power of power rule. Leaving the bottom part, the denominator alone. And then once I did that, so that will be a raised to the 4 times 3 is 12, and then b 2 times 3 is 6. A raised to the fifth power and b. Don't forget to write 1 so you can clearly see what you're doing. All right, if we separate a's, that means 12 minus 5. And then again, we're following the division rule by subtracting. Six minus 1 And this will be a raised to the 7th power, b raised to the 5th power. That's it. All right, one last thing to note, negative numbers with exponents, there's a specific rule that follows this. If the negative sign is inside the parentheses, the entire number is being raised to the power. That means the base is a negative number. So I'm going to show you here when we have -3 and is raised to the 2nd power and the negative is inside the parentheses, this means that we are multiplying -3 is our base twice. And so the answer will be 9. Here's another one. When we have -3 and negative is not inside the parentheses, the answer will be -3. So the base is not -3 times 3. So the answer will be -9. Okay, so those two are two different things. As you can see, we're getting two different answers. So make sure when you are writing a negative number, and if you know it's a negative base, you need to put it inside the parentheses in order to raise to a power. Okay, one other thing that I would like to tell you is, what if -3 is raised to the 3rd power? What does that mean? That means, again, the base is -3 times -3 and times -3. And what would that be? Now think about it. Will we end up with a negative number or a positive number? So if you said negative number, you're absolutely correct, because -3 times 3 equals 9. And then we're going to bring down 9 times -3 will equal -27. So remember, if your exponent is an odd number, then we'll end up with a negative number. If your exponent is a even number, then we end up with a positive answer. So let's try one more. Now we're taking a log and we can clearly see that -2 is inside the parentheses, so the entire thing will be raised to the 3rd power, which means our base is -2. Let's go ahead and do that. Before I write the answer down, try and guess, are we going to end up with a negative number as an answer or a positive number? So -2 times 2 equals 4, and 4 times -2 will equal 8, and it will be a negative number. Okay, so I'm going to erase this and give you one problem. See if you can, one or two, so you can do this. Okay. All right, so let's go ahead and try -4 raised to the 2nd power and -4 raised to the 2nd power, -5 raised to 3rd power. Okay, so go ahead and do that. Pause the video and try your best. Okay, so let's go ahead and try this. -4, this means if it's inside the parentheses, the entire thing is raised to the entire number. The base is raised to the power of 2, which will equal 16, and it will be +16 because our exponent is an even number. So -4 raised to the 2nd power means -4 times 4, which will equal -16. And then last but not least, -5 is inside the parentheses. That means the entire number is raised to the power of 3, and negative 5 times negative 5 times negative 5, and which will equal negative 5 times negative 5 will equal 25. 25 times negative 5 will equal 125, and of course, you guessed it, it will be a negative number. Great work, everyone. You've now mastered how to multiply, divide, and raise monomials to powers. And in our bonus section, you'll learn the difference between negative numbers raised with powers with or without parentheses. These are all the exponent skills you'll need for what's coming next, computing with scientific notations. Please like and subscribe to Teaching Math, and remember, learning math takes patience, practice, and perseverance. See you next time.